Earth in the 20th century was home to some of the most brilliant scientific minds ever to live, yet they could not foresee the destruction they were about to bring upon the Earth. Nuclear war. So here we are, in the year 2045, 30 years after half the Earth's population has been wiped out, and 100 years after the weapon was first used. So how did we get here? How did humans create such a destructive weapon? To understand that, we have to research the history of the atom, because only in understanding the atom can you understand the atom bomb. Computer, we need to go back to when humans first learned of the atom. No, computer, that's only 100 years ago. That's World War II. That's the first time it was actually used. We need to go farther back than that. The Civil War? No, that's still not far enough. I'm telling you, we need to go way back in history. Way back. Okay, now you're just being ridiculous. You've gone back entirely too far. Okay, it's about time you got it right. Stupid computers. And they say you're going to take over the world one day. So, here we are. Ancient Greece. The beginnings of modern science and mathematics. Democritus was a philosopher who came before even Aristotle and Socrates. In observing the breaking of rocks into smaller rocks, and smaller rocks into pebbles, and those pebbles ground into dust, he hypothesized that the dust must be made of even smaller parts, which he called the atom. Computer, fast forward 2,300 years. Here we will find the father of the modern atomic theory, John Dalton. He postulated that the atom was the building block of all elements, that all atoms are identical, and that the atom could not be broken down into smaller particles. Basically, Dalton's model draws the atom as an indestructible sphere. This was one of the only flaws in his theory, because to create a nuclear bomb, the atom has to be split. So computer, jump ahead about 50 years to 1897, where we stumble upon our next scientist, J.J. Thomson. Thomson experimented with cathode ray tubes, which were used in primitive radios and television sets of the 20th century. His thought was that the rays were actually particles of matter, which was heralded as the discovery of the first of the three fundamental subatomic particles, the electron. Thomson's model is nicknamed the plum pudding model because he believed the atom was a sphere of positive charge and that the electrons were stuck into the atom like raisins in a pudding. However, 13 years later, in 1910, Ernest Rutherford proved his theory incorrect. Rutherford was conducting an experiment where he shot positively charged alpha wave particles into a sheet of gold foil and studied the deflection of the particles. The majority of the particles did not deflect. And since positive repels positive, and the positive alpha particles did not deflect, this led Rutherford to create a model that has a very small positively charged nucleus surrounded by a large field of negatively charged electrons. 9 years later, Rutherford would go on to discover the proton. And 3 years after Rutherford's model was released, Niels Bohr came along to modify the model. His research was building upon the work of Rutherford, Planck, and Einstein in their understanding of the electron. Using the color spectrum, he was able to describe that electrons orbited in different energy levels. Thus, every element would emit a distinct color. Using the color spectrum, he was able to describe that electrons orbited the nucleus in different energy levels. Thus, every element would emit a distinct color. By 1932, James Chadwick was able to identify the last subatomic particle and the most important to creating nuclear war, the neutron. The neutron is neutral and is in the nucleus of the atom, and when neutrons are added or subtracted from an element, an isotope is created. Certain heavy isotopes, such as uranium-235, could then be collided with a slow-moving neutron to cause a nuclear fission reaction. This chain reaction releases a large amount of energy, followed by a large explosion. This was first achieved in the late 1930s, right before the Second World War. In 1941, at the insistence of Albert Einstein, the United States President at the time, Franklin D. Roosevelt, commissioned Robert Oppenheimer to head a team of over 20 scientists to create a bomb based off of fission reactions before Germany had developed one. In 1945, Oppenheimer was there in Los Alamos, New Mexico, to witness the detonation of the first nuclear bomb. Afterwards, he is quoted to say, "We have become death, the destroyer of worlds." The team of scientists commissioned by the President was named the Manhattan Project and included Chadwick, Rutherford, Bohr, Einstein, and many others. Together, they ushered in the nuclear age. Their knowledge led to nuclear power plants to light the largest of cities. It allowed doctors to see deeper and more accurately into the human body. It allowed for the treatment and cures for cancer. It also brought about the end of the Second World War. But for all the good they did for the world, ultimately their atom bomb destroyed the world itself.